Right, so last time we left off we had all these little things set up, and today we are going to solve a little problem we had with the user interface, specifically the buttons. And what was wrong with the buttons was, even though all this would have, we never had rotation, and we could never take the camera into account with the rotation of the camera. Because how this was working was, we had a button which was like this, and we were checking to see if it's within this axis, and it was, which if we rotated it, it would just be between, so if we rotated it to have something like this, we would just be testing this axis, which wouldn't work because, as you can probably see, it would be including all of this, which is no good. Or it would be including just the box without it being rotated, which is no good as well. So we need to start doing some maths on this, which we're going to start by using. We're going to develop a matrix class, and it's going to be a 2x2 matrix, so it's not going to be too complicated. So 2x2. You can use 3x3 as well, but the larger the matrix, the more complicated the mathematics behind it is going to be. And a matrix, if you don't know, a matrix is generally a grid for vectors. So you would have a vector somewhere like here, which would be something like 5, 6, and then you'd have a matrix. And you can multiply these together, and because of what matrices do, they have rotational values in, so it can remap this vector into a new vector. So that would be 3 times 5, which is 15. 5 times 6 is 30, so 30. It's 6 times 5 is 30, and 7 times 6 is 42, and that would be your new vector. Obviously you'd get 45 and 72 as your vector. So maths is going to be heavily used in this scenario, but essentially we can use this for rotation. By changing the elements, we're going to create a way of rotating this vector by any system that we want to, and we might be using it for something slightly different a little later on. So first of all, we need to take in a bunch of elements, and I'm going to go this dot elements equals elements, and what we actually do is, when we create elements, is we're going to take something like, I'm going to have to draw it in here just so I remember when I come to use it. So I'm just going to denote what the elements would look like if you mapped them onto an actual matrix. So when we come to use this, we know that when we're trying to draw something like this as a matrix, that the elements of element 1, because when we're using just a standard 1 by 1 array, that we're mapping the 0 index to this spot, the first index to this spot, the second index to this spot, and the third index to this spot. Obviously you can look at matrices on your... There's better people online to explain it as well as you might have had it explained at school. So there's something else I need to add in, which is a matrix identity, and I've got to use one of my notes now just to make sure that we can't overwrite the identity later on. So I'm actually going to do this time. And we're going to define a property, and property is going to be on the matrix 2b2 with the name identity, and we need it to be the object. We need to take some parameters. So first of all, the value, which is going to be 1 0 1 0. Yeah. So the identity matrix just means that when we put this together, 1 0 0 1, which is the identity matrix, and multiply it by any other vector. Let's just go for the 5 6 again. We end up with 5 times 1, which is 5, plus 0 times 6, which is 0. So I'm not going to even add that on. And 0 times 5 is 0, and 1 times 6 is 6. So we end up with the same as we put in. We need to take some other parameters now just to make sure we can't write over it. So writable is writable's got no e in it. False. So we can't overwrite it. Enumerable is going to be true. And configurable equals true. I'll be honest, I've never used this before. This is just something I've seen somebody use and it works. So whether you need these, I can understand writable, but I'm not sure about the enumerable and the configurable, because that seems like on the back end of JavaScript. So I'm unsure of how that actually works, but I know if you put these parameters in, it will work how it's intended to. So what they specifically mean, I'm not particularly sure about, although I could take a couple of educated guesses. So if elements, because we want to make sure that if this has nothing in it when it's parsed, so we can go if elements equals undefined, then we're going to set this dot elements to matrix 2d dot identity, and if there is stuff inside the matrix, the elements when it's passed, or when the constructor is called, we want it to actually assign the elements. So that's what that should be doing. Right, so now we want to make, I probably should save this file before we go any further. And it is mathematical based, so I'm going to put it in maths, and we're going to call it matrix 2 by 2, or 2b2. Yep. I didn't save it as a JS file. I'm pretty sure it wouldn't have mattered. It probably might not have mattered as long as the mimic type was JavaScript. I couldn't see it having any issues on some devices if it was just a plain text file. But even so, I'm not going to take the risk, and because a simple error which doesn't actually a simple error like that could end up being something big that I end up looking for hours and trying to fix in many different ways to end up realizing that it was just the extension name on the file, which can be a really big nightmare. So now we're going to do a set rotation. So the matrix itself, we're going to just put the rotation value in. So we're going to put in, if you put in radians, we want to rotate this element, not rotate the element, we want to set a rotation for the rotation values for the element, all the elements for the matrix. We want to put all the we want to set the rotation value for the matrix itself. So how you actually do this is, if I remember right, it's cos theta minus sine theta sine theta and cos theta. And that is how the theta is your angle and your cos is your function, to the mathematical function to actually be the multiplier. I could explain how that works, but I don't really fancy explaining it. List.elements equals a new array, and we're just going to go math.cos, and we would put it in. Now I'm putting in minus rotation for a simple reason, and that's because this here applies to y, x on the x-axis and y-axis, but in our browser we don't have y and x axis, we have an x and a y axis. Them reflected essentially. So when we want to rotate it clockwise, we actually have to put in if we want to rotate this clockwise, we'd have to rotate this one anti-clockwise because it's mirrored. We'd actually get the same if we flip this upside down, which I can possibly do if I do this. No, used to be able to do this. Is it just this? You can see these in the same now because the y would be representing the y still. It's upside down. Then maths.sine, and we've got to remember that when going to this one, not this one. So sine is minus rotation again. Now put the sine in this time, and we're going to go rotation because we're going up to this one, and it's minus sine. And lastly, we're going to go down to cos. Now, because we might use this a lot over and over and over again, a lot of times, we want to make it a little bit more efficient than most of our other code is going to be. So we have rotations on the sine, but if we know anything about the difference between sine waves and cos waves. So I'll draw a sine wave. I'll draw two waves. So here's a sine and a cos. Sine wave will be at the top, so it starts at 0 and goes like this. And if we look at the cos wave, it goes like this. And if you understand anything about what this is actually doing, is this rotation value would be on here, so on your x-axis. So if we look up, going minus or positive will yield the same value. So we can actually, on the cos, because this is representing cos, this is representing sine, we can just remove this minus off the cos, and we don't need to actually, and that should save up a very small amount of processing. Probably something inconsequential, but even so. Obviously we can't do the same with this, because when this is 1, this would be minus 1, and that doesn't work. But when this is minus 1 here, this is minus 1 here. So next we're going to do the transform equals function transform vector. So I'm going to take in a vector, and we've actually got to do all the maths behind it now. So fortunately for most people that don't want to actually understand the math side, which let's just quickly define a vector, a return vector, return vec equals new vector. Once you've done this, all you need to do is, as long as you understand what these functions do, you don't actually need to understand all the maths behind it. So I'm going to do the transform vector, and we need to do the rvec.x. So what's our new vector going to be after this vector has been transformed? So we want to take the vec.x. Just going to delete this, and so we're going to do the 0, 1, 2, 3, just so we're aware of which one's being multiplied. So we're going to do x and y. So it would be equals 0 times x plus 2 times y, and it would be 1 times x plus 3 times y. And if all we've got to do now is realise that this x represents vector x, 0 equals this dot element, 0 plus 2 times vec.y, and that's all that one's got to be. So we're going to do 1 and 3 now for the 1 and the 3. So, and all we've got to do now is return the vec. So now we've got a transform for the, make sure that's a y, not just an x. So now we've got a way of transforming a vector. Lastly, we need to do one last thing, which is going to be the determinant. Equals function and what the determinant does is it actually understands the scale of this matrix. So if we have a vector like this, we can actually make it a matrix like this, which is just 0 to 2, 0, and what this would actually do is multiply it. So in this case it would be a multiplication of 4 times the size. It's 4 times the size because it's been made twice as big in this axis as well as twice as big in this axis. So that's 2 times 2, which is 4. And the way we can actually work it out is we actually take the 0 element and we multiply it by the 3 element and we subtract it by the 2 element multiplied by the 1 element, or the 1 by 2. Because these are just standard numbers and not matrices, you can just do the multiplication in order. Which if you know anything about matrices, you know that the order is actually important when you multiply them. You can't just if you reverse the order, it does change the way the outcome matrix a lot of the time, or the outcome vector a lot of the time. So you have to be very careful in which way you actually order your matrices. So in this case we want to return this dot element 0 multiplied by this dot element 3 minus this dot element 1, this dot element 1 times this dot element 2. And that will give us our scaling factor. If you actually understand this, you'll understand that if you put minus 2 and 2, 0 and 0, the scaling factor is actually a minus 4, not just a 4. You can scale it on the negative axis as well because it's scaling around a fixed point. So it does actually correlate to an actual scaling factor of a positive and a negative, which will seem to be important later on. Save that, and in the maths we can do matrix 2 by 2, and the matrix, I am actually going to borrow this for the vector, wherever the vector is. So we have a 0 vector, which is going to be a new vector 0, 0, and we just put in the vector and we just put in 0, and now we don't have to worry about. Now I believe you can just get the value for 0, vector.0, and it should not be able to be in such a way that you cannot change it no matter how much you try to write to it. Or maybe that's what the configurable. If you can change it, I'll figure it out later if that comes up to be an issue. So back to the button. Now when we're building the button, we need to be able to do something that we can rotate and do all the matrix operations that we set up. So one of the things we need to do is go and create a new file, and I'm going to actually change the language straight away to JavaScript, and we're going to create this as a var.triangle. And this is the first time I'm going to be using polygons. So this is going to be triangles, triangle points equals an empty array. So what triangle points has got to do is it's going to store x1, y1, x2, y2, x3, y3, well, I guess it is 0, 0, 1, 1, 2, and 2, and that would be a triangle. But if we're going to also have more, so I'll just draw it so I can explain it. Essentially, we'd have 3 points, 0, 1, 2, but then we could have another triangle in the same array, and we could have it as 3, 4, and 5. So this can be as big as you like, essentially. No, I did not mean to do that. So this dot triangle equals function, and we're going to take in an ID. So how do we determine whether, first of all, if the triangle does exist? Well, we need to take in the triangle points. We want to go this dot length, and we want to multiply it by the ID. So if the ID is 0, so the 0th triangle, which would essentially be this, the first one, we're going to check if there's an element in the 5th row. So if it is longer than, is greater than or equal to the length. So this is less than the length because 0, 1, 2, 3, 4, 5, so it would be 0 plus the 5th one, which will get you the last index, because there's always 6, because there's 2 for each point and there's 3 points in the triangle. So that's ID times the ID, which is, no, actually what I wanted to do was 6. Now if 6 times the ID plus 5, this dot length is less than this dot length, then we're okay, else return null. Yeah, we'll keep it in the maps folder. Let's just add it in quickly. And let's go back to the last. Right, so what I'm returning when we do this, we want to go and get return now. I think there might be a splice method that would allow us to do this. Right, it looks like it's the slice method, which is going to be this dot triangles dot slice, and it looks like it is the 6 times the ID, which goes first, and then it'll be 6 times the ID plus the 5, and that should return us the triangles that we are using, the triangle points that we're using. Now, when we use the button, we want to check something if it's inside it. So check whether a point or a coordinate is inside an actual triangle itself. So let's do that with in the triangle class, which is going to be is point inside equals function, and point, we need to put point, and we need the triangle ID. Now we could go and get triangle first, and obviously the triangle ID would be here. Let try equal triangle. If try equals null, return false, else we're going to figure this out. Else we're going to do all the logic here. So obviously the triangle has got some data in it, so it's going to be 0, 1, 2 is going to represent all these. And we've got this point, which I'm assuming is going to be a vector, comma, array. So in this vector we need to, well, I should explain how we're going to do all this logic behind whether something is inside it. So we have to think about, first of all, I'm going to explain what the determinant does, which I already have sort of explained it as a scaling factor, but that's not the only thing it can do. If we take a matrix with equals v1, comma v2, or you can use line, basically that's concatenating two vectors together, so that would make a matrix. And essentially, if we have a line like this, let's make it a bit smaller, we would have v1 and v2, assuming they start, because it's just a directional vector, we can assume they start at 0, 0, and the determinant would determine, so this would be another representation of v1 and this would be another representation of v2, and we would have this sort of square polygon. Now the determinant tells us the area of this box. Now but what we need to know is whether it's minus or a plus, whether this area is minus. So because this is, if we look at v1, this is counterclockwise or anti-clockwise, and that's where all the area is. We can know that is a positive area. Whereas if we take another example where v1 is above v2, because v2 is going to be on the lower end, and we have, well, this would be v1 and this would be v2, this area here, because this is clockwise, then it is a minus value, the area. Now why is that important at all? Well, when it comes to doing triangles, we need to know a few things, and the way I'm going to figure out if something is inside a triangle. I want a better triangle than that. And we're trying to determine whether a point is within a triangle, which let's just say this is a point here. we are going to just take in a line and the angle between the line. Then we're going to do another vector. I'm going to test the angle between this vector and the vector of the triangle and the vector from this point to the point we're testing. And what we should see is all of these would either be positive, right? Because all these angles would be actually a positive from if we go in one specific direction, it would be positive away from it. So this would be, I don't know, 10 degrees. This might be 10 degrees, and this might be 160. But given all that, so that should be something like 160. And none of them actually go in the opposite direction to the actual cross or the point, no matter where we drag it inside it. But as soon as we drag the point outside of the triangle, over here, suddenly we have something that has a minus value, and because we're testing it against this edge here, this would also have still have a positive value. It'd just be a very large positive value, and this would also still be positive. But whereas this was always positive, this value, this is now got one negative and two positives. And you can also think, if we flip this upside down and measured it, so this is 1, 2, 3. And we created another triangle the same. Draw this upside down. Two, 3, and 1. So now you can see this triangle's upside down. You'd notice that if we're going in that specific direction, that this in this case would be a minus. And hold on. Two is measured from the 2 to 3, so if I cross here, 2 to 3, this would actually be a minus. This would also be that's a 3 to 1, which is a minus, because it's going in the opposite direction. So whereas this went clockwise, or no, this went anti-clockwise, and this is going clockwise, we can see that all of them would be the exact same. So this would just be it'd just be a different sign. So as long as all of them are the same sign, so this was a plus or a negative, it works. But as soon as we got a minus or a plus, it's outside. So what we can do with this is, instead of having to work out all the angles and whether or not they are moving clockwise or counterclockwise or anti-clockwise, we can actually just look at the area and see whether it's positive or negative, and it will do the exact same thing as what we were just doing here. So that's all we've got to do, is use the determinant function, which now I'm also going to use. I'm going to make a raw version of this, and I don't want to use, I want to make sure it's a static function, that way I can use it as much as without having to create an instance of the matrix. So we can put in x1, y1, x2, y2. So now I need to know what the x1 is, which was going to be the x value of, which would be the first x value. Two was going to be the y value, the second y, the first y value. X2 would have been the first element, and y2 is the fourth element, yeah. So that would have just turned into x1, x2, y1, y2, and that would just be in M, and then you just find the determinant, and it would tell you whether the area is a minus or a plus, because the scaling factor would essentially just be this area when you find the determinant of M. So now we know the maths behind it, or hopefully you understand some of the maths behind it, or I've completely confused you. At least I'll know what I'm doing, theoretically. So we've got to look at all these points, and we've got to use the differences between these points so we can actually get the vectors. So if we look at vector 1, so we're going to go from x1 to x2, so that would be try 2 minus try 0, and then that is your x value, and then we look at vector 1 for the y value, which will be, just going to add 1 to all of these. So vector 2 x is now going to be the one from the point, so we go point dot x, because we want, so when you do a vector you always want to take your endpoint minus, so a to b equals b minus a. Right, so we've got to take away the endpoint to the start point. So the start point on this case was 0, 1, which was the x0 and y0. Now we're just going to use the same values here because we're trying to get from C also. Yep, so because the point is another point and we're taking the line off the triangle, so this will be the point, so we minus, so a minus c and a minus b. At c minus a and b minus a are the two vectors that we need to use, and that would essentially be representing b on the x and the y, then we minus the a and this is still representing a, and this would be representing c. So y, and then we will just go let angle 1 equal to matrix 2b2 dot determinant I will have to check whether or not I have spot determinant right at some point. And we're just going to put in vector x, vector y, vector 2, and vector y. I'm actually going to declare these slightly differently so I can just copy and paste the code, because I'm just using these as placeholders for the time being. Because after all, I did say we're going to try and do this as optimized as we possibly can, and so far creating a bunch of variables is not the most optimized way we can do this. We can just pass the values as raw. But just to make sure that we know what we're doing, I'm going to do this first. So this will be 1 and this will be 2, this will be 1 and this will be 2, this will be 3 and this will be 1. Oh, no, this will be 3 and 0. Almost made a very bad mistake there. This will be 2, this will be 0, this will be 2 and this will be 0, this will be 0 and this will be 1. And these would need to be 2 and 3. Okay, so now we've got the determinants, which is a representation of the angle sign. So it's not really the angle, it's just the positive or negative that we're looking for. So I think these are right. So 0, 1 is 2, 2, 2. Whenever there's a 2 in the previous one, it should be 0. And I feel like there's a 3 missing somewhere. I don't know if there's a 3 in there, it should be a 0. Oh no. Oh. I'll completely ruin this. Okay. You're supposed to add 2 each time, so 2, and when it gets to 6 we return it to 0. Right, so 2 plus just 3, and this will be 2, and this will be 3, and this will be 4, and this will be 5, which makes more sense. 4 and 5, and this would be this wasn't even right. Yes, it was 2, so 4 and 5 and 6 doesn't go to 0, it goes to 0 and 1, which is correct. And that should in theory work now. So we'll leave it for the time being, and we will optimize it slightly when we can check all this works. So this is something we're going to do, and this is going to be triangles equals new triangle. New triangles. I actually want to change this to an S because it can represent more than one triangles. More than one triangle. So let's think how this has got to work. So on the setup, I'm going to actually just generate the triangle itself. Maybe we can do add triangle. We can take in 3 vectors. And in this case we need to do the it wouldn't be push, it would be concatenate. So I've just got to take the triangle points and do .concat, and in this I just need to put all my vector stuff in. So vector1.x, vector1.y, vec2.x, comma vec2.y, vec3.x, and vec3.y. And now that should add all these elements to the list, so I can just put them in as vectors rather than having to put them in as raw data points, which should be much more comfortable. So all I have to do now is work out what data points I want to put in, which is, in this case, I want to take the size and I want to put new vector. In this case, we're going to take the x first and we'll put in minus, I'm going to put half, and then the y coordinates is going to be this dot size dot, I need to put dot x, and to make it just a little bit easier to read, I'm going to put them in a row so we can see what values we're actually putting in. So dot y divided by 2, and we want it to be a minus. So this is going to be on the other side, so it's going to be a positive, so I'm going to add that on, and this has got to be, yeah, that can be the same, this has just got to be different. And you know, we might as well add both triangles in at the same time, which now just means you have to work out in your head which way around you just put these. So this should be the first one, this should be the second one, and the third one should be both positive. And now we should have both triangles, and just to check that this works, I want to be able to draw them. So now I'm going to do the drawing outside of it just so we can make sure everything's right. So now we want to get all the triangles from here, so stop get num triangles, and this will just return the number of triangles that are stored in the array. So how do we get this? Is we just take this number, the length of the array, and we just divide it by 6. And that should give us all the number of triangles inside the variable. So this dot triangles, num try equals this dot triangles because I've only used this dot once. For some reason I didn't put it in here. This dot triangles, this dot triangles, this dot triangle. Oh well. Get number, and then we're just going to loop through it. I is less than num try I plus plus, and now we should be able to go through every single one of these. Get triangle. Yeah, we just got to get the triangle now at each stage. Working on this one, so I'll drag it to the end. And we just put I in here just to represent the index of the triangle that I'm trying to get. So try data, and we won't put anything in try data except for this in the loop. So now try data is going to get all the information of each triangle. So have I ever used, yes, so I'm just going to now draw the triangle. When we pick up a triangle, I want to just pick up the data of the triangle. So we've got 0 to 0, 1, 1. So we want to set the start at 0, 0, yeah, so begin path. I'm going to do move to first, which it was already moved to. So then we need to draw the next one, which is going to be line 2, which in this case is just going to be try 0 to 0, 1, 0, 2, and try data to 0, 3, 4, then that would be 6, which would be 0, which is 1, and then we would have drawn the 5, yeah. So now this should have drawn, so this moves to the start of the triangle, this draws a line to the next point of the triangle, draws the next line to the next point, and draws the line to the next point. This doesn't matter as far as I'm aware, and we're not doing a fill at the moment, so, and this is at the end, so we know that it will just draw a triangle, so we'll draw a triangle on top of anything that we've already drawn, so it should be useful. And let's see how many failures or errors we get now, which is undefined triangles is not defined, but in 12, which could mean that I didn't add triangles to we had triangles, and that's going to annoy me now, so I need to get rid of this and re-import it as an S. And let's go again. Oh, triangles is not defined at new button, so it's possible that I brought in the button before I did the triangles, which I haven't. It's possible that the core is firing before anything else. On load setting, although it should be done at the very end, so it should have already loaded everything. Temporary setter. Did I set this up wrong? So did I not put the equals function? I did put the equals function. Let's just try making a new triangles. Interesting. Core.maths.triangles.js. Core.math.triangles.js. Let's just look at the other error. Triangles not defined at button.time. Triangles is not defined. Just check. It's not just an importation problem. If I do new, okay, so it's not importing it properly. Did I spell triangle twice? Why is it not loading in? Maybe it's bugged out, I don't know why it would be, but looks like it's still broken, so triangles, unless I've spelled it wrong in here. Triangles. It's not one of these angel things, is it? Where I've put angels instead of angle. Yeah, and that would explain it. Right, it's not drawn it, so that's not a good sign. Or then again, I could just go into this and remove all the draw functions. So Matrices. Get triangle I. Seems to be working. Let's do a well, let's not do it there, let's do it on the start. That way when it's set up we can at least see if not it functions. And I'm going to put 0 then. So there is no, it's not inside a loop. No. Okay. Let's just try a few things. Triangle dots. Add, and we can just use all this. The only thing we've got to do now is let's just make a temporary size thing, just so we can test something. And triangle points has not been written to at all. Okay, so use add triangle. I add new vectors. Point vectors. And it hasn't added anything to it. Okay. Just stop concat. Because I need to make sure it equals. And now we can try that again. And this time it's added some information to it. And for some reason it's only 75 back when it should have been 6. It's no good for me, which means I need to get triangle 6. Still isn't drawing, or maybe it is drawing, it's just not drawing in the right place. Because everything is a minus right now, so except for this value. Right. I could remove all the divided by 2s, make it twice as big. And hopefully the crossing point and when it's in a positive y, I could also multiply it by 5 or something like this. make it very big. Okay, so this is interesting. So I only use the. I could just copy this. Restore it after the fact, and that should now move it just right back to the center. It does not. So is there some reason why this would not work? Didn't want to go through all this all that scene, that layer, debris, that actor, that 0, UR user interface 0. Triangle. Get number of triangles first. Let's just see if so that returns 2, which is correct. Get triangle. If I put 0 in, I should get a set of coordinates, and if I put 1 in, I should get another set of coordinates. They look similar but then different, so that's working. Why is it not drawing? Try data 0, try data 1. And this is in positions 0, 0, so it should just be drawing it in the center. Why is this not? Oh, I need to put stroke in, and that should now draw it, hopefully. Yeah, so now we have a triangle. And now we can add a matrix onto our own new matrix 2 by 2. And that should just set the matrix identity. And for now we can just do this.matrix dot set rotation to maps dot degrees to rads, which is going to be somewhere. I have forgotten where I use it. To radians. I'm going to use degrees to rads. And we're going to multiply it by the rotation value, which is 0. And we might as well do this every frame, because why not? And where's matrix 2D, so 2 vector. And let's put in a raw vector so we can do the this without any difficulties of having to cast it back to a vector, then back down into data form. So if I take that matrix and I now put in these values, this dot matrix dot transform vector, could use the one that I've just literally just written for it. And we just pass all these variables back in, and it will just return us to this. Doesn't take a vector, it takes a single value. Right. Just for now, see it, just to make sure it works. Cannot read property of matrix 36. Cannot read property of what? Of 0. Oh, so simple. And this is actually just this, because we're actually returning the matrix. Elements, it's fine. Now if I get the button, which this is the button now, so the rotation is 20, I'm rotating 20, we're rotating in the wrong axis for some reason. but nevertheless we are rotating now. And if that's the wrong axis, then we could just simply take this out, this correction that I thought we needed to put in, and suddenly it should rotate in the right direction, which it does. And now if we haven't actually put the click logic in, it's just now we can move these triangles in this specific direction. We can now use the logic that we built in, so just click within the bounds on both triangles and it will determine whether or not we've actually clicked in the boxes that have been drawn. And it's just always return true on there anyway, so so now we're going to use the triangles instead. I'm going to use the triangles instead, which means we could use this information up here, and in fact I'm only going to rotate the mouse position currently. So this dot matrix set rotation to be the negative rotation. This time we're doing it this way, and I'm going to apply it to the mouse. So we're going to do the mouse equals this dot matrix. So this dot matrix, I've got to do the transform vector, but this time I'm not using the vector raw, I'm just using the vector mouse, and once that's been transformed we can now use the detection to see whether or not the point is within these triangles. So is point inside triangle, which we did not complete. So if because we have to check whether or not these are positive, so and 1 equals is greater than 0, greater than or equal to 0, or yeah, we can just do and 2 is or equal to 0, and 3 is greater than or equal to 0. Negative And we're just going to flip these around. For some reason I hit the dash instead of 0. Now we return if pos is not equal to negative. If the positive is not equal to the negative, then it should return true. And is inside, so we can do now triangles. Need to leave through all the triangles, which is simply this. We have the step triangles, triangle, and we've now got to put the triangle ID, which is just the eye, and the first slot was the point, which is going to now be the mouse. So we pass the mouse in, we check if it's in the point, and we should be good to go. Right, on the showing point, yeah. So can't read property of 2 and triangles 28. Fair enough. Should be checking if it is equal to null, not is it not, make it null. So okay, so we have finished this. So let is in equal false. If this returns true, then we return true. And if it doesn't, obviously it'll get catched by this false statement at the end. So if all of these are positive, if all of these are negative, let's try positive equals negative. Is in equals yeah, I don't even need this. So if point is inside triangle, so these two are the same, or no, if these two are different, then it is inside, because it cannot be positive and negative at the same time. Let's just do a couple concept logs. Okay, so we should see where the might be being rotated more than it needs to be. How do I fix this? Yeah, let's draw just a simple little cross where the mouse is. Let's use 5 and 5. And then obviously we need to draw the +5, and we need to do the stroke. I can remember where I'm working. Here. So is it inside it? And it's not returning positive, so unless there's something wrong with these, which means the determinant might be wrong. It's not clicking at all. Oh, wait a minute, did I? That'd be why it wasn't clicking. It was never calling it. Means I've got to redo all this. Event manager dot invoke event. I can just put 0 for now. One of these is activated. Fine. Oh. That's never. I'm thinking that the clicking is not relative to the camera. Whether this would be 0, 0, but the mouse is not being rotated, moved based on the position of the camera. So minus equals the camera.position.x, which would explain why everything is always wrong, and hopefully x is not defined on bottom 40. Mouse.x, which is defined, camera.position.x should also be defined. Camera. X is not defined. No, but camera.position is a vector. X should now be defined. X should be defined. Mouse.minus. It's the only thing I can think of. Maybe they haven't done a minus equals, but I think they have. I'm pretty sure they have. Being clicked. It's not equals. Right, so well, this looks more promising, and this might actually be wrong. So might be because being clicked. This should have been very easy, but it seems that the rotation, I've got no clue what's going on. Could also be that it's mouse.y, not mouse.x. Work shot, maybe. Obviously it's not. What I'm trying to do is rotate the mouse so it's behind it. It's being clicked over there. It's not being clicked over here. I'm just thinking the easiest thing I can do now is just rotate every single coordinate inside the stop point, because this is going to return instead of rotating the mouse, rotate the triangles. Let's just make a static version of this for a little while. Inside triangle raw, we put point, and then we put try array. I'll just copy this, and instead of doing it, place try with try array. So then we can just get the triangle itself, which we've already done once down here. Let's try data on the loop itself. Let's try data, try none, which has been gotten rid of. Try none, don't get try data equals, we don't want to do this now. I've got to convert try data into 3 vectors. Try 1 equals new vector. Try data 0. Try data 1. Let 3 equal this, then we can get the maybe a matrix, but that's fine. 2, 4, 3, and 5. Now we'll just do the matrix transform wherever I did that, which I must have done somewhere because everything is rotated. So transform raw x. Try 1 equals try 1. x, try 1.y. Three, 2, 2, and 3. Now let's remember this needs to take an array. So now all these have been transformed. I need to just take into account the mouse and just go and grab this. From the point, we don't need the actual two. So the point is now going to be the mouse. The array is going to be try x by try y. And hopefully this will be good enough to merit an actual rotation. Just need to check now if this is true. We want to return true. I am getting fed up with this. Try one switches. Now let's just add on this dot position, which we can't do because this is a vector. Plus equals this dot position dot x. Two and 3. Control D. Control D. And then just convert all these x's to y's. Could also be because I haven't actually moved it to the camera. Which means I've just got to do camera. This, and because camera is just the position data, I am going to just put it to this, and it's obviously going to be a minus, not a plus. And clicked, not clicked, not clicked, not clicked, not clicked, not clicked, and if you click inside it. That took a lot longer than it should have done. And if I rotate it now, nothing, 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 nothing. But it does click when I rotate it. So I'm going to have a lie down, and that's about